All right, welcome back to Computer Science 50. This is the end of week 8. So much fun stuff on the agenda today. But first, lunch tomorrow will be held with me and some of the TFs at both 12 and 1. Go ahead and RSVP if you would like and can't normally make Fridays. One, an apology about the cloud. So several of you who got a jump start on the project have noticed over the past couple of days there would be delays with the cloud. This doesn't so much have to do with how many virtual machines we were running or anything like that, but rather yesterday an interesting bug or perhaps feature in Valgrind, whereby there was a couple of students who had written their code for the dictionary implementation in such a way that they were using malloc or realloc in such a way that Valgrind, when run on their code, was using 10 megabytes of RAM, and then 20 megabytes, and then 100 megabytes, and then 1 gigabyte, and then 2 gigabytes. And so what was happening yesterday, we determined that a couple of times during the day, multiple students happened to be running code like this with Valgrind, and in short, the machines ground to a halt. And bad things happen if you try to allocate gigabytes and gigabytes and gigabytes of memory on a machine that doesn't have hundreds of gigabytes. But we have since imposed resource limits on the machine so that programs like that will be terminated prematurely. Realloc or malloc will return null specifically if you try to allocate 10 gigabytes of RAM, and it will do so more quickly this time. So we hope that that will avert some of those problems. So my apologies if that caused some frustration. Between Glenn, Cato, and myself, we were pretty much online the past 24 hours dealing with it. So know that if you're feeling it, odds are we are as well and are simply working on it. But do report as much on the bulletin board. So yeah, to be clear, griping in office hours or yelling in office hours may be helpful cathartically, but Glenn and Cato and I don't hear it. So do drop sysadmins at CS50.net a note so that the right people know what's going on. Okay, final project time. Believe it or not, this semester is almost over. Only a couple problem sets left, and the final project specification is now available on the course's website. You may recall from the syllabus that there's a few different components to it. The first of which is a pre-proposal, which is actually due this coming Monday. This is meant to be a very casual but important step whereby we require you to do some thinking this weekend and to drop an email per this PDF, per this printout, to your teaching fellow by Monday at 1 o'clock with some ideas, or at least an idea, so that you can get the juices flowing, so to speak. You can do a bit of a sanity check. And to be sure, we've just now this week begun the web-oriented stuff in the course. And many of you will like to go down that road. And so quite understandably, you might not yet have a good sense of what's even possible. And that's fine. But you know how to use the web. You know what kinds of websites are out there. So assume for now that you can do almost anything. And propose as much to your teaching fellow, and they will perhaps help you with a sanity check if you're trying to implement, say, the next Google or the next Facebook all within just a couple of weeks' time. So the steps following that are the proposal, a design and framework submission, a quick status report, the CS50 fair in January, and then finally the implementation. So this thing's not due for a couple of months, but there are several milestones per this document that you'll want to hit. And I noticed there's just one typo in the printout. I accidentally said projects at fas.harvard.edu instead of projects at cs50.net on one of the pages. If you email, if there is someone at the school with the last name projects, they'll be getting about 300 emails by accident. So I'll update the PDF online, but just change any mentions of FAS to cs50.net. Any questions about most anything? No? So today's silly, stupid internet news, I thought I would tie into our discussion of Google. This actually came out a while ago, but there was this chatter several months ago, maybe, yeah, just under a year ago, about how much money Google's I'm Feeling Lucky button costs. So out of curiosity, how many of you, upon going to Google, the real Google, have, or make a habit of clicking I'm feeling lucky? Okay, so that's pretty good. So it's like 1%, right? And which is actually what this article claims. So you and several other people in this world are costing Google, according to someone's calculations, $110 million per year. Because I think one of the founders, Sergey, mentioned that 1% of their folks actually use that I'm feeling lucky button. And what's just cute about this comment, if it is in fact accurate, is the following. So about 1% of all Google searches apparently go through the I'm feeling lucky button. Because the button takes users directly to the top search result, that's what it does if after all these years you've never actually clicked on it, Google doesn't get to show search ads on, obviously, 1% of all of its searches. That costs the company around $110 million in annual revenue, according to Tom Chavez. So why does Google keep such a costly button around? It's possible to become too dry, too corporate, too much about making money. I think what's delightful about the I'm feeling lucky is that it reminds you there are real people here. Google exec Marissa Mayer explained, or at least tried to. So, legacy reasons perhaps, if nothing else. But we implemented fake Google on Monday, and pretty damn well, right? This thing actually works. If we wanted to search for something like I did, like Google and cost of I'm feeling lucky, even though all I really did on Monday was implement the HTML, turns out my little fake Google does in fact work. And that's because we were using an HTML form, but we were redirecting the contents of that form not to our own website, not to our own database, but to Google's. And so today's focus is about how to do things like that. On Monday, we looked at web servers, we looked at file permissions, we looked at HTML and CSS, and we hopefully gave you a conceptual framework in which to dive into those things this coming week. It's in section, and it's with the problem set in your hand that you'll actually learn more about HTML and CSS on a need-to-know basis, looking up tags as you need or want them. But today we dive into PHP and SQL so that you're actually doing something dynamic. You're not just displaying sort of a 1990-style blinking web page, but you're actually responding to users' input. The page is changing based on what users are doing, based on what users have uploaded. So this whole silly phrase called Web 2.0, which essentially means that content is driven by users. Well, it's precisely languages like PHP and databases like MySQL that enable that to even happen, because you can store data that's inputted not by you, but by other people. So that's our focus today. So in fact, let me go ahead and actually pull back up Google.html, which I sort of cleaned it up last night. We included a printout of it in here called Google.html, just so that you have a reference. But what I want to turn your attention to is what's going on behind the scenes, and then we're actually going to implement some of those behind the scenes stuff ourselves. So this is just Firefox. I'm on the internet. I'm on CS50.net, where I've put this .html file. If I go to view page source, recall that it looked a little something like this. And I've nicely indented it this time. I've cleaned it up. But this is valid, hopefully, XHTML. OK, so notice that the form that I have defined goes to the action attribute of http://www.google.com/search. So at that URL is not a .html file, because .html implies static content, but there's some kind of program, a program written in Python, written in C++, written in PHP, written in Perl, whatever language Google has decided to implement their search program in, at least the user-facing portion of it. To put this into context, you are all probably using Facebook quite a bit. Much of Facebook still is written in PHP. So the language we're about to dive in today is what Facebook, at least in the user-facing context, is written in. Supposedly they use other languages behind the scenes for optimization purposes, but PHP, as you can see by the .php files in your URLs, is what that site, for instance, is written in mostly. So with that said, let's see if we can't replace this google.com/search program with a little something of our own. But first, how does this work? Well, remember that the protocol that web browser and server speak was called what? So HTTP. All right, so HTTP is what the languages that server and browser speak, but it's HTML or XHTML that these web pages are written in. So who cares? Well, if I go ahead and search for something like CS50 in Google, what I'm going to do before I click Google search, what I'm going to do is go up to the Tools menu in Firefox and pull up this Firefox plugin that I downloaded. So if you've never used Firefox, what's nice about it, at least for web developers, is that there are many, many plugins out there that you can install that facilitate making websites, making web pages that interact with a server. So what this is going to do is show me all of the HTTP traffic that's going between my browser and Google's web server. So when I said last week that the message that a web browser sends to a server is something pretty simple along the lines of get /index.html or something like that, space HTTP/version number. Well, this is precisely the kind of data we're going to be able to sniff using this program. And we'll see why this is useful in just a moment. So I'm going to go ahead and now click Google Search. Everything seems to happen as normal. If you've ever wondered, CS50.com is actually a cordless telephone website, which is why they come up there first. But now let's see what's happened in this window. So I've essentially just sniffed the HTTP traffic between my browser and Google server. And it's a little cryptic looking, and there's actually a lot more going on in these messages than just the get string. But notice it is in fact there. This is the most important message sent by my browser to Google server. And I'll go ahead and zoom in there. What you'll see, whoops, user error. Let's do that again. So what you'll see if I zoom in on top here is that, yes, get is in fact sent. Now I got to scroll back up. Let's do this once more. Clear. CS50. Search. There we go. So if I look at the very first thing that happened up here, well, it's complete. I don't want complete. All right, let's do that again to keep it clean. All right, going to google.com. I just completely derailed this demo. All right, CS50. Enter. I'm in charge of your cloud, too. All right. So here we go. So now I've just sniffed the HTTP traffic going back and forth. So notice the most interesting line so far as we care today is that get string. And it's apparently getting not index.html, because that would be some static content, but /search question mark, and then some interesting stuff. So anything after a question mark in a URL is what's known as a parameter, an HTTP parameter. And you can provide input to a web server by way of key value pairs, a parameter and some value. So we actually saw these before just the other day. If I pull up google.html, it looked a little something like this. And recall that I had this input tag here. And then I had another one below it, and a couple of more down there. And the most obvious one for us to focus on for a moment, perhaps, is this one, button G. So BTN capital G is just the arbitrary variable name, parameter name that Google chose for this thing. And then they gave it a default value of Google search. Well, not only does that have an aesthetic effect on the page. For instance, I can change this value to be fake Google search. I can go back to our web page and reload at CS50.net in our version of it, and now it says fake Google search. So it has an aesthetic effect, but now notice what happens if I actually sniff this same traffic. I'm going to clear our log. I'm going to go ahead and type in CS50 again into my version of this, click fake Google search. Same results come up, but now notice up here that in this top line, does it say button G equals fake plus Google plus search. So what's happening in this get string is that after the question mark comes variable equals value, ampersand, variable equals value, ampersand, variable equals value, ampersand. And what are all of those variables? Well, it's whatever you have chosen yourself or Google has chosen to define in your HTML file. So here's a name of HL or H1, whichever it is, HL I think, button G, button I, and there's one here Q. Well, take a guess. Which is perhaps the most important one here? Or what's the most powerful one to change the value of? Well, if we look at the results of what came up a moment ago, where in fact is my query in this string? So it's Q. So Q, short for query presumably. It says ampersand Q equals CS50. And so that in fact is what's driving the results. And notice in fact you've seen this before. If we look at the URL at the top of the browser, you know, it often gets very cryptic. Even on Facebook and many other sites, you get all this junk at the end of the URL. And maybe it's useful to some people, but generally it doesn't matter because it's just telling the web server what to show you. And in this case, what it's telling the web server to do is to invoke the search program, and then following it is the question mark, which says here comes a whole bunch of variables and values, parameters and values. Well, the first of those is called HL equals EN, whatever that is, probably something to do with English. The second one after the first ampersand is Q equals CS50. Then ampersand button G equals fake Google search. So you can pass in values by way of buttons as well, but it's the text field, of course, that was useful here. If I want to manually do this, it looks like a plus represents a space. So you know what? I want to be more specific. I don't want this Plantronic CS CS50 phone thing. I instead want CS50 at Harvard. So I'm going to say Harvard. So CS50 plus Harvard, manually changing the search string. And now we become the topmost hit. So it's as though we've completely circumvented the search form just by replicating now manually how I'm providing input to Google's web server. And that's it. So just as early on in the course you used getString to get user input and getInt and getFloat, when it comes to getting input from users in a web page context, you're going to use HTTP strings, but not that you're going to usually hard code as we just did here. But you're going to generate those strings by whipping up a form and letting the browser figure out that this form means when the submit button is clicked, that content should get submitted to the web server as just that one long string. Now, there is one exception to this that you'll eventually see perhaps in the problem set, which is that if you're trying to submit non-ASCII data, for instance, you're trying to upload a photo to Facebook or Flickr or some site, odds are you're not going to put that photo somehow in the URL string. So there's kind of a reasonable limit on how long a URL can be. It's not standardized, unfortunately. But anything longer than a few hundred characters, 1,024 characters, is probably getting unreasonable. It's getting unsafe, lest some browser not have a buffer that big. So there's another mechanism that web pages use and that you might use in the problem set or final projects. And that's not even specified here, but you can specify it. There's another attribute that the form tag takes that's called method. By default, it's called get, G-E-T, as implied by what's going on. But you can also use post. So post is used when you actually want to submit a whole lot of data. And now let's notice the effects. I'm going to go ahead and click back on fake Google. I have to reload the page so that I reload the HTML. Otherwise, even though I saved it in Nano or Vim, it's not going to propagate to the browser until I just hit reload like I did. And now if I hit search and type in something like CS50 space Harvard, watch what happens with Google. So the method post is inappropriate. So Google, for security reasons, for just design decisions, decided not to support this. But if by contrast you go home tonight or this afternoon, try uploading some stupid photo to Facebook and install this plugin and look at the headers that are going across the wire as you're uploading that photo. And instead of seeing get, you'll instead see post, and you'll actually see perhaps your photo or part of it in a really weird sort of encoded way. So there's various tricks for encoding binary data when you have to send it just across the internet. And so what will really go across the wire is things like letters, alphabetical letters and numbers that happen to represent bits, but in a nice sort of text-friendly way. And actually, I think this plugin won't actually show you that just because it would be kind of meaningless to a human. But when it comes time to start developing this stuff, if you go to the resources page on the course's website, you might have overlooked them up until now, but we do have a bunch of things on the website. Do I have to uncomment them perhaps? Yeah, so we have PHP links here, SFTP. Oh, and under software is where I believe we have links to, Firefox, live HTTP headers, another program called Firebug, which is wonderfully useful. But these are more sophisticated tools. I would say, though, as you tackle the next problem set, I don't care much for the religious debates around browsers, but Firefox is really useful when it comes to developing this stuff because of these plugins. So consider downloading that. So now let's do something more powerful. So with XHTML forms, you can have not just text fields and buttons, but some other things as well, with which you're certainly familiar conceptually. You can have password fields that just show little dots when the user's typing in a password. You can have checkboxes, radio buttons, drop-down menus. So all of the mechanisms you're familiar with from various websites can you implement with little snippets of code just like this. So let's go ahead and now do something interesting with this. All right, so let's go ahead. I'm going to open up a file just called frosh.ims. And I'm going to put a little 2 at the end of it just because I'm going to fake this a little bit. I'm going to skip those headers for a moment because I never remember the doc type stuff at the top. But I do know there has to be HTML there. I know there has to be head. I know that there has to be title up here. And it's frosh.ims. All right, so close title. And now I need the body. So that's the essence of a web page without the other stuff at the top. All right, what am I going to put inside of this? Well, I'm going to go ahead and have a form. And I don't really know what the action is going to be yet because I haven't really thought that far ahead. But the method is going to be get. And now I'm going to close the form. And now this is going to be, for instance, the web page via which freshmen sign up for intramural sports. And I'm actually choosing this intentionally. Before there was Shuttle Boy, the very first web programming I myself ever did as a sophomore was to teach myself Perl. Again, after having taken 50 and or 51 at the time. And Perl at the time was very in vogue for making websites. Nowadays, PHP and Python and Ruby and other languages are perhaps more popular. But I taught myself this language by picking up a book actually called Teach Yourself Perl in 21 days. I read the first 7 pages of it, first 7 days worth of content from it. And granted, it took me several years to finally learn the other tricks that I would have gotten to if I read the rest of the book. But that's to say, picking up new languages after something like C, at least if they're similar syntactically, really isn't all that hard. And that's, again, one of the lessons of this week. So one of the first projects I did as a sophomore was organize freshman intramurals with my roommate. And literally back then, you would pick up a piece of paper from some central office. You would write your name on it if you wanted to sign up for I am soccer or I am football or whatever. You would then walk to a specific proctor's room in Wigglesworth, slide it through their mail slot, and voila, you were registered for freshman intramural sports. Like, this was some very low-hanging fruit. There were computers in 1996. And so we were able to solve this with the internet at the time. And we did, my roommates and I, something very similar to this. We whipped up some fairly primitive web pages, then wrote some code in Perl, we'll do it today in PHP, so that we could do things like this. So that I could do something like name. And then I could say, all right, I need an input field. The name of this field is going to be the person's name. So a little coincidental there. Let's see, the size of it is going to be like 40 characters. I don't really care so much. Now I'm going to ask them for their dorm. So dorm, for now I'll be lazy and I'm just going to say let them type it in. Size size equals 40 again. And now let me ask them for their email address, let's say. So email. All right, so email. Now I just need a way of submitting this thing. So I need an input type equals quote unquote submit, and then the value of this button, whereas before it was Google search, I'm going to do something a little more sensical like register. OK, so that's my quick and dirty frosh.im's form. Yeah? Extra, yes, thank you. Good. And they're even highlighted in a bad color. So that's gone and that's gone. Good, good eye. All right, so any other problems you foresee? There are some. Let's blindly forge ahead as though I know what I'm doing. All right, so this is frosh.im's 2.html. I'm about to click this link. Stop me. What's going to break? Forbidden, right? We've sort of beautified what it means to be 403 forbidden, but this thing is 644, the chmod command from the other day. So that fixes that problem, hopefully. Let's go back to frosh.im's 2. Wow, that's pretty ugly. Works, maybe, but it's pretty ugly. What are we missing from the file? Yeah, so line breaks. Again, so you could teach a whole course or at least learn some lessons from friends on design aesthetics. We're not going to dwell on that here, but at least we're cleaning it up a little bit. Still pretty hideous, and you probably should be embarrassed if you sort of launch with this version of the website, but at least we have something somewhat functional. So the idea back then was that I would go up and say, I am David Malin, I'm in Matthews, and my email address is this. Unfortunately, when I hit register, I sort of haven't implemented the back end, so to speak, the program that's going to do something with this data. Now, do look at the URL. Notice that because I submitted it to an action of quote unquote, the browser just assumes you mean submit it back to yourself, which may or may not make sense. But notice that we do see how my form has translated into a nice get string with the ampersands and the equal signs, all following that one question mark. So we seem to have the basic workings of a program there. But we now need to do something with it. So I need to do something like implement a program called register.php that actually does something with this information. But now I clearly need some PHP skills. So PHP is what's called an interpreted language in that it's not compiled. So whereas a compiled language like C means you write source code, you run it through a compiler, you get out object code, and then you run the object code. With something like PHP, you just write source code and then run, in a sense, the source code. But you run it not through a compiler, but a program called an interpreter. And there are differences between these two types of programs that we won't bother with in this course, but there are performance implications. Compiled languages are generally faster because you actually get zeros and ones out of them as opposed to interpreting a program line by line as PHP is going to do. But for us, this means the following today. If I load up, and I can do this with Nano, so register.php, I just start, oops, already made that one. Let's call it register2, so it's not prefabbed. Register2.php, I've just got a blank file here. So every PHP file, no, has to begin with an open bracket, question mark, PHP, and then a close, question mark, close bracket. So the top of your file must be that, and everything else must be, and the thing must close with those tags. Now you'll see that you don't need to have these at the very top and very bottom, but just like in HTML, the HTML tag says, hey browser, here comes a web page. What this is going to tell the web server, hey web server, here comes a program that you need to execute, and not just spit out to the user as though it's some XHTML file. So you know what, I'm not going to quite implement something useful yet. I'm going to kind of cheat and just implement a little old hello world program. And it turns out the syntax for that is pretty simple. Print hello world, semicolon. I'm going to go ahead and save and quit. I'm going to go ahead and go back to my directory listing here. You'll see register2.php exists. I'm going to click and it worked. So there is something to bear in mind with permissions on PHP files, partly for security reasons and partly for intellectual property reasons. They don't need to be world readable. They just need to be readable by you, the owner. Otherwise, the implication would be anyone could sort of steal the intellectual property that constitutes your source code. Whereas HTML, XHTML, in that it's more about aesthetics, you can't really hide that from users. Who cares if they see it? But PHP doesn't need to be chmoded 644 as do these other files. In fact, your code might not work on some web servers if you try to make it too publicly accessible. Now that's all fine and great. Register2 works, but it has nothing to do with frosh.ims.html. So I need to now tie these two together somehow. So I'm going to go back here, and just because I renamed the file, I'm going to call it register2.php. Now unfortunately, if I go back to my form, frosh.ims, I registered David and Matthews and Malin at post register. Well, that's great. Right? Still not really helping the user. So we're almost there. Right now they're tied together somehow. And notice the URL did change as we would expect to mention register2.php. So that's progress. Now we have to do something with this data. So let me load register2.php back into my text editor. I obviously don't want to do this anymore, but I want to do something with the data. Well, first let's see how I get at the data itself. So in C, when you've been writing programs, you use argv and argc to get at the data. Well, in PHP, you're going to use a few variables called super globals. So global variables that sort of automatically, thanks to the web server, are filled with all of the stuff the user provided by way of some HTML form. So there's a few of these super globals, just to see a list. And we'll glance at just a couple of them today as it relates to solving these problems. But they are these. So there's $_ something. And two of these are perhaps very topical right now. $_get and $_post are global variables that automatically are going to have inside of them, when my code is run, any of the parameters that the user provided via some HTML form. So all that stuff from the URL gets parsed out. It gets analyzed by the web server, broken out from what's really just a long, ugly string, and broken out into a more interesting array structure is what we're going to see. So let's go ahead and take a look at this. If I want to look at the contents of this variable, this is a quick and dirty trick. This isn't useful yet, but it's interesting. I'm going to print _r. Print recursively the following, _get. And that's it. All right, that's all I'm going to do, just for diagnostic purposes. So now I go back here. I'm going to go back to my form. It's still filled out. I'm going to click register. Okay, interesting. So now I'm seeing the data. I'm not doing anything with it, but clearly I can get at the data. Now this is a little hard to read. What I'm going to do is a little HTML trick. Up here, before I start printing out that variable, I'm going to print out an HTML tag called the pre tag. This means pre-formatted text. And if you've never seen this before, it just means like print everything in Courier font. So that mono-spaced font that you see us use with source code. Now if I print that first and I resubmit, it's just going to format it more nicely. All right, and if I look at the view source for this page, it's the same thing. Right? And that's why that's useful. This is not valid XHTML. This is sort of quick and dirty hackery, because right now I just care about telling a story. The story being, how do you get at data that the user submitted? Now guess what this is. So this is, okay, so it's an array. Guess harder what this really is. What data structure is this representing? Someone say it out loud. What does this look like? It's a, okay, it looks like a struct. What type of struct? Or what kind of data structure more generally? Yeah, okay. Associative array. Yes, which we've never mentioned in the course, but that's correct. But it's also a synonym for a hash table. So remember that hash tables, which some of you have been playing with this week, and we certainly talked about last week, are data structures that map keys to values. Now, sometimes those keys have been students' ID numbers. Sometimes they've been student structures that we looked at briefly. If you're trying to figure out where in a hash table to put a student, well, you might hash to the location in the array based on their ID or based on their first name using the ASCII codes. Then you end up having a chained list of some sort. But last week, and for this current problem set, you guys have been worrying about the implementation details for a hash table. Wouldn't it be nice to just assume that if you need to store stuff in a data structure and you just want to be able to put something at a location based on a key value, who cares how it's implemented underneath the hood? Let the language store it for you in an intelligent way. That's precisely what PHP does for you. What this is an associative array, associative in that it maps not numbers to words, but words to words in this case, or it's a hash table more generally. So this is wonderfully useful because it means I can now get at these fields and do some interesting things. So I'm going to go ahead and write a quick little web page as follows. So I'm going to go ahead and start writing some HTML here, just so that I can be proper. I'm going to cut corners for time's sake. So just realize, do as I say, not as I do. I just need enough to get the browser to show me this stuff. I'm going to say something like hello, comma, and then I want to put their name here. But I'll get back to that in a second. You live in dorm, and your email is email. All right, so I kind of like to fill in these blanks now. So I don't really need PHP up here, but I need it inline in my HTML. And this is why PHP is neat, because you can intermingle it with HTML. Some stuff will just be spit out literally by the web server. Some stuff will be executed, that is interpreted before it's spit out. So notice this might otherwise be a very simple web page. In fact, at the moment, if I reload, it is. Hello, name here, you live in dorm. Your email is email. But notice, I have all those variables in the URL. So can I now plug them in? Well, it's really easy to plug them in. Recall that I said a moment ago, anytime you want PHP code to be, you just have to say open bracket, question mark, PHP, space, some stuff. I don't know what's going to go there yet. And then I close the tag. So this is sort of a PHP tag. Now I can put any lines of code in there that I want. I only need one. What do I want to print here? Print. I want to print out, let's see, $_get. Now this is an array, so I can kind of guess that my syntax is going to use angled brackets, just like C. But now I need to know what to put in here. Well, what's powerful about associative arrays, arrays whereby you don't need numbers like 0, but rather words. Well, if I want to get at the key called, what was it called? Name, that's all it takes. So let's go ahead and save this. And notice there's a lot going on here, but this just says here comes some PHP. Here's no more PHP. Inside it says print. This is a function. In parentheses are its arguments. Same stuff as from C. What am I printing? Well, I'm printing out the value in this hash table at location quote unquote name. Now I'm not implementing a hash function. I'm not implementing chain lists. I don't even have pointers in this language. But that's not the point. The point is now we're operating at a higher level language like PHP, where a lot of these details are taken care of for you. And you can finally start writing code more quickly. It's more fun. You can solve problems more easily because you don't have to worry about some of the lower level details as you do in C. So now let's go back here and reload. All right, so now we have some dynamism. And if I look at the page source, notice there's no mention of my PHP tags because, again, PHP is executed server side, whereas XHTML is parsed or looked at client side. So that's the difference. Now it's going to be easy to plug in my dorm. You live in dorm. So I can do print of $_get dorm. Right? And I could neaten this up if I want, but I'll just let it wrap for the moment. Now I'm going to scroll here. Your name is email, so let's see. I need to do, oh, and notice there's shortcuts. Even though the proper safe way to do this is open bracket question mark PHP, most people and most web servers are totally fine with you just saying open bracket question mark. It's a little faster, saves you 3 keystrokes over time. So print $_get bracket email quote unquote semicolon, still important usually. There. Now let's reload. Ah, what's wrong? Close my parentheses up here. Good. So it's an unintentional lesson, but one you'll inevitably trip over anyway. Parse error, syntax error occurred. So where is that? It looks like line 4, and indeed I'm on line 4 at the moment, and I missed that thing. So again, you'll get some somewhat cryptic messages, but again, some tips as to what line they're on. So that's pretty cool, but kind of useless, right? Can't email me just by clicking this as you can in most websites. So let's do something a little fancier. So first of all, I have to be more cooperative and actually type in my whole address if I want that to work. So that was a user error. But can I now turn this into a hyperlink? Well, in general, the means by which you make hyperlinks is like this, because we didn't do this the other day. So let me just make some space. You have an anchor tag, hyper reference to http cnn.com, and then, so hyper reference to that, where do you want it to go? Link to CNN is what the link is actually called. Okay, so close bracket A for the anchor tag. Reload, there's the link to CNN.com. So I hover over it, and you see in the bottom left corner of my screen that it's indeed going to CNN.com, but the text that's displayed is what's outside of those brackets. Okay, so that's sort of a lesson we can now infer from. Now let's turn my email address into something clickable. So instead of just printing the name, I need to do something a little fancier. I need to, outside of this, say href equals quotes. And now I need my email address to be inside those quotes, so that's fine. Let's just skip over here to put the close quote outside of that thing. Now close bracket, because this is closing the HTML tag. Now I can say email me, close angled bracket, period. All right, so this is completely grammatically wrong at the moment, but let's take a look at the effect. Now it's clickable, all right? So your email is email me, right? A little overzealous there. But if I click on this too, kind of broken, because there is no mailinetpost.harvard.edu URL on this server. So you actually need a little trick. When you have an emailable link, you'd put, say, mail to before the address. So if I save that, reload, this looks the same, but now in the bottom left-hand corner, like most websites, it says mail to mailinetpost.harvard.edu. If I click it, it will launch Outlook, which will take forever, so we won't do that. But it would send me an email. But this obviously should not be email me, because that's not grammatically correct. So if we want to do it again, all right, well, in this case, it's not too much of a copy-paste job. We'll do it one more time. It's blue for a moment. Oh, that's right, because I need to, again, tell the program, here comes some PHP. That's it for the PHP. And now, voila. So we have some basic building blocks. Now, suffice it to say, for now, there are ways of not just spitting this data back out, right? That'd be a pretty useless Frosh IM's program if you try to register for a sport and it says you're registered for the sport, but there's no persistence. Like, there's no saving of that information to disk. But it's very easy, we'll see in PHP, to save that kind of data to disk, to email someone, to send an email, to store it in a database. Well, let's take steps towards that, actually. All right, so let me go ahead and take a step back and say just a couple of things. So PHP 1 is one of the nicest languages to learn from after C because it's so damn easy. And the manual online is so user-friendly. There are examples of functions. There are discussions of functions to do more complicated things. It's a very easy beginner's language to pick up, which is why we do it, because we're only going to spend a couple of weeks on this. And you can really bootstrap yourself by just understanding sort of where it all fits into the picture between browser and server. You then look up most of what you want, and you learn by way of example. And that's certainly how I learned. I learned PHP sort of as reference over AOL Instant Messenger by just pestering a friend a couple of years ago with question after question after question, because he had already taught himself it. So that sort of speaks to the accessibility of this stuff. What does the manual look like? Well, you'll get very friendly with this next week with the next problem set, but pretty much you're not going to have to read the whole thing. Most people use Google, frankly, to find things in the manual. But if I wanted to learn a little something about that printr function, well, search the function list for printr. And here we go. Here's the documentation. Printr prints human readable information about a variable. Here is the signature. Now, there are different data types in PHP, which we'll mention briefly, but it looks like printr takes at least one argument. Apparently, it takes an optional argument, as square brackets usually suggest, and it returns a data type of type mixed. So what's kind of nice and kind of not nice about PHP is that it's very loose when it comes to data types. You don't declare the types of your variables. If you want a variable, you just say $foo and start using it. You don't have to pre-declare it. You don't have to specify the type. However, underneath the hood, PHP does kind of understand differences between bools and integers and floats and strings. Often it doesn't matter. And it doesn't matter often because PHP is often used in a web page context, and everything coming in off the web is text because the user provided it via the keyboard. So there's a lot of automatic conversion between strings and numbers and strings. But just know that when you're reading the documentation, For clarity, at least to the developer, the manual will tell you what data type is being returned, but it's very easy to just blindly treat a string, a quote-unquote 2-3, as though it were the decimal number 23. You don't have to do any of that subtraction of capital A, none of that low-level stuff. A lot of this just happens automatically for you. So that's just to put in front of you some of that jargon. These super globals will be useful as well. Some of them, like get and post, for your final projects, if you allow users to upload files to the server, you'll use $_files. If you start using cookies, as we will today, all of those things are stored in $_cookie, and there's some other features there. Arrays, though, are worth noting because there is a wonderful kitchen sink in PHP when it comes to array functions. So I just pulled up this URL, and you know how in C there's really no functions that relate to arrays? You have to sort of implement everything yourself, including the checking of the length and all of this. Well, in PHP, anything you can imagine doing with an array kind of exists. Like you can sort, you can iterate, you can intersect, you can splice, you can reverse a list, you can add, subtract. I mean, everything is given to you. And so this, again, makes it very easy to pick up this language quickly, because if you need to do something, odds are you say something to Google like PHP merge two arrays. How do I do that? Oh, the array merge function. And it exists, right? And this is why we need not spend that much time on it in class proper, because it is so easily self-taught. So there's looping constructs, right? Now think back to Scratch. We saw this in Scratch. We saw this in C. We're going to see it now in PHP. We're going to see it next week in JavaScript. Loops come in the form of for loops and while loops, whose syntax is almost identical. Do while loops exist. And then there's a couple others, like a for each statement, which still does the same work, but it gives you another angle. Just like while loops and for loops give you a different way to solve the same kind of problem. Just to show you how you can use this, I will whip up my famed ugly web page again. So here was mailinrouge.com. Let me go ahead and pull this up. This was in our examples directory called index.html. All right, so not all that bad, right? It's pretty good, mostly Photoshop work. Let's say I really like this, and I'd like to show you my logo 10 times. Completely arbitrary, but it'll let me do a loop. Now I'm in an index.html page. You know what? I'm going to copy this to an index.php page, which is the default name for a PHP-based website usually. I'm going to load it up in, whoops, I'm going to go ahead and open this file now. That's OK. And it's still the same, notice. Notice it's still the same. So let me go back to the directory listing, reload. Here it is. It's identical. Notice that the size is 211 bytes. It's the same file, and yet it works. So you can, so this is not writing PHP code, right? Like PHP, anything that's not inside of open bracket question mark and question mark close bracket is just raw data that's spit out to the browser, because it can be intermingled. So if I actually want to do something cyclically here, like really annoy the user, you know what? I can do something really hideous like this. Open bracket question mark. For I gets 0. I want to show you this thing, let's say 5 times. I is less than 5. I plus plus. And now what do I want to do here? So it's a little unclear how I can do this. So I'm gonna cheat for a moment. I'm going to do the following. I'm going to indent this just to make it a little more readable. And I'm not going to print this thing out raw, but I'm going to use my friend the print command. So print, I'm going to use single quotes so that I can commingle them here. So that should be safe there. And there's one last thing I need to do to close this construct off. What am I missing? Yeah, so I just need to close that. So with PHP 2, white space doesn't really matter so much. So you try to stylize it in such a way that it's very readable. And we start relaxing the expectation that your code not be more than 80 characters. The reality is with XHTML and PHP, it's kind of more readable if you just let the lines grow long sometimes. And so that's increasingly OK here. So if I didn't make any syntax errors, this is going to be a completely stupid web page. But if I reload now, notice that, wow, look at what I've done. Right, let's look at the source just to see that this is in fact happening server side. Notice, yep, look at all of those mailinrouge.jpg instances. Now even though I have this white space, notice it's not printing. If I really wanted to do that, I could print out something like print \new line. This is going to have no effect on the web page, because again, XHTML does not care about white space, but now my source, did I reload? Now my, why is it not showing? What's that? Oh, ooh, yes, this is like quiz 0 question, wasn't it? Yes, you similarly need curly braces. Exactly was my point. All right. So view page source. There we go. So now it's still ugly, but that's OK. So what you'll find in this part of the course is we do expect that your source code be pretty, but the output, in as much as it's being generated by a computer, it itself does not have to be nicely indented and whatnot, because you will drive yourself nuts trying to make it look good on both places. And in this web computer part, parsed by the parser, parsed by the browser, who really cares? Now let's do something slightly more interesting. So this is going to look a little overwhelming at first, but it speaks to the power of this technique called regular expressions. And this is a feature that exists in many languages, just not C. It exists in Java, it exists in Perl, PHP, other languages still. And what regular expressions allow you to do is pattern matching, checking if some string matches some value. And this is wonderfully useful if you're trying to validate user input. If you've ever tried to visit a site where you type in an email address and then you're yelled at by the website, that's not a valid email address because you just typed in ASDF because you didn't want to fill out the form. Well, how did they know that ASDF was not, in fact, an email address? Well, they probably looked for what sort of hints? The @ sign, maybe the presence of a couple dots, maybe for a TLD like .com or .edu. So we can do some fairly sophisticated things if we now have regular expressions in our mix. So let me find an example here. OK, so let's start doing this. So let's say, spoiled that. Let's take a look at this, and let's tie some of these things together. In the login directory for today, and you have a printout of this, is a whole bunch of examples that increasingly sort of raise the bar as to what you can do with PHP. So the very front-facing file here is just called home.php. And the goal at hand is to implement sort of a very simple login system. The next problem set 7 is going to have you guys implement CS50 Finance, your own E-Trade-like website where you're going to let real users or fake users trade stocks. You're going to give them all $10,000 or so by default in their portfolio. And then by way of hooking into Yahoo Finance's semi-live data feed for real-time quotes, you're going to be able to allow people to buy stocks and sell stocks and keep track of what stocks they have. Now to do this, you're going to need to remember who's logged in, much like Facebook and any other website has users and passwords. Well, we're going to implement the beginning of that here. So this is a page that's obviously saying I'm not logged in. Well, version 1 of my login program is going to be just as ugly as the frosh.im stuff, but now I'm going to be able to do something interesting like log in with an existing user like J Harvard with the password of Crimson, click login, and now notice I'm still at home.php, and yet this same page is now telling me I am logged in. So somehow there's this ability to remember that a user has in fact visited the page before, and in fact there's going to be a way to hook into a database to see what user in fact is logged in. But first, why don't we take our 2-minute break? All right, we are back, albeit a little abruptly there. So before we forge ahead with this login example, let me show you a slightly better work of art that I prefabbed before today. So in your packet of source code today, the first file, froshims.html, is the source code for this thing, which clearly takes more than just text input fields. So when I said a moment ago, you can have drop-down menus and radio buttons and all these things, these are all familiar user interface mechanisms that you've seen before. But if you poke around at the source code for this thing, you'll see how I actually implement it. And recall I said on Monday that you can actually use, if a little, or rather abuse, tables in an invisible sense to lay things out. Well, notice that inside froshims.html, again, first page of today's handout, notice that inside my form element, I actually have a table, but the border is currently 0. Let me change that to 1 just to show you what's going on, because we'll use this same approach in the problem set. It's just kind of a nice way of laying things out in a standard tabular form, albeit in a hidden fashion. So you can do this in other ways, but you'll find this to be one of the easiest ones. So back to the story of logins, because now we can finally do some more interesting things. So in this page, I seem now to be logged in, but what's kind of neat is this. I'm going to remember the URL. Now I'm going to go to like google.com. I'm going to do some stuff. And now I'm going to go back to, what's this going to give me? Okay. So not all software is perfect. So now I'm going to go back to that same home page, and notice I'm still logged in. So much like websites you're familiar with somehow remember that you're logged in, CS50's own website does this, and does it even longer if you check that box. Somehow my browser is remembering that I'm logged in, or conversely, somehow the server is remembering that I'm logged in. Now, just from our brief discussion of TCP/IP and your own experience in life, you probably know that IP addresses, such as those assigned to your laptops, are not static usually. They can change whether you're in Starbucks, whether you're on campus, whether you're at home. So your IP address often changes, especially in a mobile place like this. So it doesn't suffice for a web server just to remember your IP address, to remember who was logged in from where, but rather web servers have to plant little reminders on your hard drive so that they can remember in this way who you are. And these are these things called cookies. And I stole my own thunder earlier, but this was to be our segue to cookies. And a cookie in a browser sense is just a tiny little file or a tiny piece of memory that a web server has planted in your browser so as to remind itself later who you are. So in fact, remember in our live HTTP headers plugin earlier, there's a whole bunch of stuff that's going back and forth here. Well, if I go ahead and reload this page and go to, let's see, reload this page, notice what went across the wire here. So I'm going to zoom in again. The first thing you see is, again, the get string. There's a whole bunch of other stuff, most of which isn't interesting to us. But one is the second to last line here where it says cookie, colon. Well, what PHP does for you automatically when you're using it in a web page context is it plants on a user's computer, if you call the right function, a cookie called by convention PHP ses ID, for session ID. And then the value of that variable is apparently a really long looking string. It looks like some kind of hexadecimal string or maybe just an alphanumeric string. Now that's really large because PHP generates these things pseudo-randomly. So when you get a cookie like this on your computer, there's a very low probability someone else in the world is going to get it too. But odds are that's not going to happen. But what's useful now about this cookie, this key value pair having been planted in my browser, is what my browser is supposed to do henceforth is any time my browser requests more content from this website, my browser is supposed to send back that cookie as sort of a reminder, hey, I am David. Hey, I am David. Or really more generally, hey, I am really big random number 1, 2, 3, 4, 5, 6, 7. And so, and what's happening on the server side is the server's just remembering a whole bunch of stuff about user 1, 2, 3, 4, 5, 6, 7. In its database, really, in its file system, the web server can remember, for instance, your username, your password, any number of other features, your Facebook preferences. So the fact that these things are remembered, even when you sometimes don't re-log in, is because the server is somehow remembering them server side, but it's remembering who you are by asking you to sort of present a hand stamp every time you revisit the web page. So the fact that this PHP sesh ID is sent automatically by my browser is sort of like your readmittance. The browser is holding out your hand for you saying, this was me, number 1, 2, 3, 4, 5, 6, 7. Let me pass and remember who I was. And this is really useful because if you want to remember that someone is quite simply logged in, you have that ability. So how are we doing this? Well, rather than write this on the fly, I'm going to go into our login directory and look at login1.php. So this is clearly more code than we've seen before, but notice what I've done. If I scroll down to the bottom, notice that here is the form. So one of the neat design decisions that we'll walk you through. So the next problem set will hold your hand through some of these design decisions so that you actually know where to begin and you don't have to completely take a leap from these lecture overviews. This file here, recall, looks like this. Well, that's going to take some XHTML, and here it is inside of this file called login1.php. And just to be clear, login1.php. Well, it turns out you can have a form, as we've said, submit to itself. So before I just did quote unquote, and by happy coincidence, Firefox assumed I meant submit to myself. To do that more properly, there's a whole bunch of variables available to you in PHP. This $_server just provides you with access to a whole bunch of information about a user. In fact, if you want to see this really quickly, let me go to my index.php page from a moment ago. Instead of doing this nonsense with printing out my logo this many times, let me up here make a complete mess further and do something like this. Now I'm going to do print r $_server just so you can see what's inside of this. And I'm just going to ditch the rest of this for now. I'm going to close my pre tag just to be anal. I'm going to change the background to be white. That's the hexadecimal code for white in a web page context. And let's see what this gives me in index.html. So this is CS50.net, index.php rather. Whew, whole lot of stuff. Doesn't help that I'm centering it. Let's get rid of the centering And now this is what's inside of that big super global hash table. Now, most of this is not useful. Some of it is. You can see clearly what the user's IP address is, which is maybe useful if you want to log their activity for security purposes. You can see what pages they've specifically requested in this case. Suffice it to say for now, there's just some useful stuff in variables like that. So what am I doing next? Well, in login.php, here's the form. Notice I'm defining a field called user, a field called pass. And notice this type is of type password, which is why I got those bullet marks when I typed Crimson. I didn't see J Harvard Crimson doesn't show up because it's a password field. And then I have this input type equals submit, which is just the login button. But where is it getting submitted to? It appears that it's going to get submitted to itself. So what does that mean? Well, if you're submitting to yourself, well, what's going to happen first? At the top of this file, we're going to do the following. This first stuff is just comments. So thankfully, there's at least something familiar to us from C. Down here, we're calling a function that I looked up in the PHP manual that's called session start. And this says enable sessions. And a session, as my ever so technical slide is meant to convey, allows you to remember information about the user. For instance, what's in their shopping cart or what their username is. So thanks to cookies being planted on your computer, PHP provides you with access to a superglobal called $_session. And in that session, can you toss anything you want? And this is going to be really useful for the stock portfolio tool that you'll be implementing, because there too, can you remember who is logged in and details like that? Well, let's see what's going on here. Even though the code looks a little new, the constructs are familiar. Here's how I went ahead, just for demonstration purposes, and defined a constant in PHP. A constant called user, a constant called pass, and I just hard-coded these values. Well, how am I checking that this form actually works? Well, when I click submit, that data is getting submitted back to the same page. And what's happening first? I'm first checking if this is set. So what does this mean? Well, this is saying if this superglobal's variable called user is set. That is, something was typed into this variable, and what else is true? The password was also set. That is, there's something in that variable. Well, what do I then want to do? Well, then I want to check, does the variable that the user typed in equal the constant? And does the password the user typed in equal this other constant? And if so, what am I going to do? Well, this is all it takes to remember that you, the user, are logged in. You can tuck a true value, a Boolean, a single bit, true or false, in this super global called session, because later you can just check that variable called authenticated to see, is the user in fact logged into my website? That's all it takes. And PHP automatically makes sure that you always have access to this global variable simply because you called this function here. So you get that sort of for free. Now this stuff down here I'm going to wave my hands at because it's copied pasted from the user manual. But what this is doing is saying, after you've done this, issue an HTTP header called location : and what this thing is it means go back to home.php. So I've submitted to login1.php. This single line of code is saying now redirect the user to home.php. So to see that all in action, if I click login, let me go ahead and pull up my live HTTP headers and clear them. Click login, and notice very quickly do I end up back home. So I'm back home, but notice what happened in my header, in my sniffer here. So the first thing that happened is that form was posted, not get, posted for security reasons to login1.php, if you can see that toward the top of my screen. And then notice what happened down here. What happens after a request is the server's response. Apparently the server responded 302, moved temporarily. And this is the result of my having done, and I can only highlight it by shrinking it back down, my having issued this header here. So all that other stuff got spit out automatically, but the fact that I said, hey, location equals ... home.php, that's telling the browser, you know what, there's nothing for you here. Issue another request, this time for this URL. And so if I scroll down in my sniffer here, the next URL that in fact is requested, as I've just claimed, is home.php. So in this way, do you have this ability to have flow control? Like you can submit data to one page, you can do something with it, check it, and then redirect the user to another page if it's in fact not legitimate. Now taking a look at this source code and the conditions I've used, what happens if the user's username or password are not correct? Is there an else condition? So So there doesn't appear to be an else condition. There is an exit. So after the location field, after the success happens, I seem to just exit because that's all I need to do. Issue the location request and let the browser go away, go to where he needs to go. But what's going to happen then if this if condition and this if condition are not both true? Where do I end up? Well, you keep executing what's in the file, which means the user sees if they provide a bogus, for instance, username like Fred with whatever password, well, they're going to get kicked back to the same screen. How did I do invalid login, incidentally? Well, this is kind of neat. So if the count, if the number of values in the post array is greater than 0, implicitly, what does that mean? It means the user had just clicked submit, right? Otherwise, there's nothing provided by the user if you don't hit submit. So if there's something in post, that must imply that the user reached this page by clicking the submit button, in which case they only can get back here if they screwed up their username and or password. So you know what? I'm going to yell at them with this echo statement. So there are many different ways in which you can implement this logic. And so one of the takeaways from this example, if a little more complicated than the first ones, is that all the constructs are the same. It's if conditions, it's else's, it's setting variables, it's checking values, and then it's printing some of the aesthetics of HTML like last time. Now, let's take things up a notch, because this clearly does not scale. You probably in Facebook, Mark Zuckerberg's not sitting at his keyboard hard coding in your usernames and passwords every time someone registers. Right? There's a database going on there, and at least back in the day, probably still, actually still, they use Mysql as one of, or their primary database engine across thousands of servers. So you too, for this next problem set, are going to be making use of a database called MySQL. So MySQL is a very popular, freely available database server. We are going to install this for you on the cloud and then provide you with the ability to create databases for yourself on it. So what you'll see in problem set 7, we'll walk you through this. You're going to be able to log into a blue page that looks a little like this with your cloud username and password. What you're then going to see is what's generally called a web panel. So DirectAdmin is also the software that was donated to the course, and it just simplifies the process of managing an account on a web server. So it's going to be running on the cloud for you. There's going to be a whole bunch of options, and one of them that's relevant for now is MySQL management. So again, the problem set will walk you through clicking this link. You can notice I was playing around earlier. I created a database called Mailin Bar, Mailin Lecture. Let's go ahead and create yet another one. I'm going to click Create New Database. I'm going to call this Mailin Real for the real lecture. I'm going to give myself a username of Mailin Real, and the password will be Mel Brooks 12345. 12345. I'm going to click Create. And now this is very empowering, right? I've just created somehow a database for myself. A database is just a place like a huge Excel spreadsheet where you can store values, rows and columns, if it's a relational database. And that's what this is. So the other tool, problem set 7 will introduce you to, is another freely available tool called phpMyAdmin. This is just a nice web-based tool for managing a database. So I'm going to now log in with Mailin_real and the password 12345 and click Go. What I'm going to now get is this interface, which at first glance is a little confusing, but notice here's my database on the left. And again, to reassure, problem set 7 will walk you through this. Now I have the ability to create a table in my database. So a database, or a relational database, as things like MySQL and Oracle and SQL Server and Access, if you've heard of these products before, they're relational databases, which just means that you store data in them by way of tables. And tables, as you know, have rows and columns. So what this is asking me now is to define a table in my database. Well, the goal at hand, recall, is just to improve upon this very simplistic username password system. So how many columns might you imagine my having? Or if you were to store all this data in a spreadsheet for a student group, I mean, how many columns do you need for this problem? Right, just 2, right? This is pretty straightforward. So I'm going to say this is going to be my, let's call it users table. The number of fields I want is going to be 2. All right, so now I have this mechanism here. So it's asking me a few questions. It's asking me to name the field, that is, name the column. I'm going to call it the user field. I'm going to call the other one the pass field. And then I have to specify a type. So just as in C and kind of sort of in MySQL, there are data types, or rather in PHP are there data types, so are there data types in MySQL. Fortunately, they're pretty self-explanatory. The only one we're going to use for now is either char or varchar, because most of these others, date and time and int, don't really apply for this username password idea. So I'm going to say, all right, these are var chars, which means variable chars. Think of this as synonymous with string. But I do need to tell the program up to the maximum length of my username and the maximum length of my password. You know, anything's reasonable. I'm going to choose, say, 64, just to be arbitrary, but a power of 2, just because I'm a computer scientist. 64 for pass. And now this rest of this stuff is kind of useful sometimes. So this column here is asking, can this field ever be null, that is empty? Probably not. Like, you don't want a bogus username or a bogus password. So I'm going to say both of those have to be not null. Extra doesn't really apply. You can do auto incrementation of numbers, but this stuff on the right does. So it's using icons here. But in a relational database, there's this concept of keys and primary keys. And what this means is that you are asked in advance to tell the database which of these fields has to be unique. So you don't want 2 Malins in your database. You don't want 2 J Harvards, because then you can't really distinguish who the person is, one password from the other. So we might say that, you know what, I know that the field that uniquely identifies rows in this table is going to be user. So this icon here, if you hover over it, says primary. I want user to be a primary key. What I don't want to say is I don't want to say password should also be unique, because what's the implication then? Right, then no 2 users can have the same password, which is just kind of nonsensical and would kind of confuse people if you couldn't choose a password someone else had already chosen. Now there's other constraints here. You can say it's not a key, it doesn't unique, it's not used for looking people up, but it must be unique, and you can also choose an index. So for performance reasons, you can also hint to a database, you know what, I'm going to usually be looking up users by way of their username. Optimize this field. So use whatever fancy tree structure that you've been implemented with to store usernames so that you can find them quickly. I don't want to be doing linear search through 1 million users in this table. I want you to find it quickly. So specifying keys and indexes, as they're called, means look for these things quickly. And that's it. I'm going to go ahead and click Save. If I did everything right, notice that what's just happened is this. So MySQL is a database engine, but SQL, structured query language, is itself a language for talking to databases. And we don't bother in this course sort of walking through some of the minutiae of some of these queries, just because it's not very interesting. But all phpMyAdmin did for me was, in a more user-friendly fashion, is execute that query, the create table query. So back in the day, before there was this program, phpMyAdmin, we could still do this in this course, but you guys would be typing this stuff at the command line, much like ls and dir and other commands. This is just more user-friendly, and you can sort of learn by way of example, because again, as we've seen, when you create a table, well, it wasn't all that hard to pick the type, because it shows you in a nice drop-down what's possible. So now let's patch into this. So now I have a database running on the server. Now I need to actually hook into it. So what I'm going to do in login5.php is somehow connect to a database. So this is pretty much a copy-paste from login1.php. I literally copied and pasted the files and renamed it, but I've added a couple of lines of code. This line here and this line here, one of which is designed to connect to that database, and one of which is designed to select a database. So what am I going to fill in here? Well, you know, I never remember. So again, one of the lessons today is I have no recollection of how to use a MySQL database in PHP. Thankfully, someone else does. So PHP MySQL connect. Well, there's the manual page. All right, it apparently takes a string for the server name, a string for the username, followed by a string for the password. And that's why I left these 3 blanks. All right, well, the server name is going to be localhost in this case, because the database is on the same server as the web server. The username I said was malinreal. The password was 12345. And now the name of the database was, by coincidence, malinreal. So I'm just filling in these blanks from your lecture examples. Everything else, almost everything else, is the same. So what is different? Well, this line is the same. If the user submitted a username and a password, do the following. But now, whereas before in login1, I was just checking the values of these 2 constants, that no longer makes sense if I now have a database and I'm trying to look up the user. And so what's powerful about SQL is its ability to let you query the database. So this one line of code here is constructing something very similar to what we did a moment ago with create table, but there's other commands that you can execute in SQL. One is select, One is insert, one is delete, one is update, and there's others still. But using these very simple primitives, can you add data to a database, remove it, and look for it? And what we care about doing right now is looking for it. So what I'm going to do is execute one of these commands. If I want to find a user in this database, in general, what I would do is this. I would say select, and then what do I want to select? Star. Let me select everything, the entire row. And this is a little small, so I'll enlarge it in a moment. But select star from the table. The table was called users, where, you know what, let's say user equals quote unquote J Harvard. Now, if I go ahead and execute this query, what's going to be returned conceptually? Hopefully nothing, because I didn't actually put anything in this database. Right? So what I can also do with phpMyAdmin, if I click Browse, and then if I click the Insert tab, you know what? I need to give it some I need to populate some fields. Let's add J Harvard. Let's add 1, 2, 3, 4, 5, and click Go. Okay, notice what it's done. This is the stuff you would have had to type at the command line if you wanted to insert that data. phpMyAdmin has done it for us. If I now click the Browse tab, it shows me, just like Excel does, what's in the table. So the only thing in this table right now is J Harvard with a pass of 1, 2, 3, 4, 5. If I want to get a little fancy and insert a Jane Harvard and give her the same password, which is OK, click Go. Now click Browse. Now we see that, in fact, the table is growing, just like Excel would if you add another row to the database. So that's all that's going on here. But now we want to select, say, J Harvard's password. So what I could do with this SQL language is, well, let's select pass from the users table where the username equals, quote unquote, J Harvard. So again, that's what that looks like. So, and I'm capitalizing just to be clear. It's case insensitive, but I'm being clear. To distinguish values from commands, notice what came back. So showing rows 0 through 0, 0 indexed, confusingly, 1 total. Query was pretty damn fast. Let's zoom in. What was returned? Just the pass. So we returned a row, but just the password field. Now, who cares? Well, let's go back to the code. Notice that I'm actually using sprintf here for reasons I'll explain in just a second. But notice that I'm really just defining a string. So select star from users, where user equals quote unquote $string. We've seen that syntax before. It means put a string here. All right, what do I want to put here? Well, really what I want to insert is the user's name. Right? Isn't this exactly what I did in the previous silly example with frosh-ims? I just started writing a real string and then I added a value to it. But because there's no HTML at this point, I'm using sprintf, which is saying put here whatever's in this variable. And this is what the user typed in. All right, now what happens next? So now I have this string. Now I issue the MySQL query function. I do some error checking. If the result comes back false, something bad happened. And a popular function name in PHP is die. It just means kill the whole thing off and yell this error message. Could not query database. Die is usually a bad thing. If you're getting there, something's wrong. But it's a cute name. But now we can do this. Check whether we found a row. So if the number of rows returned, so what a database returns is a result set, sort of a mini spreadsheet containing whatever you asked for. Go ahead and fetch an associative array from this result set, so from the table returned, call it a row, and then check, is the pass field in that row equal to the pass that the user typed in via the post mechanism? And if so, go ahead and set this flag to true, redirect the user, and we're done. So let's see if I made any mistakes, if this actually works. This is login 5. So if I go back to login 5, which is over here in our login directory, login 5. So it's J Harvard 1, 2, 3, 4, 5 login. OK, it seemed to work. Now, granted, we're kind of hiding some details, so let's prove that this is not a fake lecture. Let's go back to Browse. Let's go to this thing, right? Pencil means edit, so let's manually edit this thing. Let's change it to a 6 at the end, thus changing his password, kind of like what Glenn and Cato and I do when you guys forget your passwords. All right, now I'm going to log out and try this again, login 5. OK, so J Harvard. I'm only going to type in, though, 1, 2, 3, 4, 5, no 6. Log in. OK. So it's, in fact, rejecting me. I didn't bother with the error message this time, but it's rejecting me. But if I try J Harvard, 1, 2, 3, 4, 5, 6, log in, It appears to be working. So what you'll see if you poke around for reference for this next problem set through login 2 through 4 and then beyond is just incremental steps toward making more sophisticated login programs using these same basics, tucking away a reminder in the session that the user's logged in. But what will become useful, especially in this next problem set, is to know that MySQL also comes with not only data types in these commands, but also functions. So these functions here are going to let me format strings in a certain way and encrypt certain things. Hey, still got like 3 minutes there. I'm going to save the best for last. And there are more sophisticated queries that you can execute. So this too will be helpful. So imagine for a moment how you might go about implementing an E-Trade database. You're going to need a table for users, so you remember their usernames and password. And then to remember that a user owns some stock, you're probably going to want to remember the stock ticker symbol, the quantity that they own, and maybe even when they bought it, if you want to be able to tell them what their profit or loss is from the time they bought it. So you can imagine constructing an Excel spreadsheet or a database table that contains that kind of information. But if you want to now merge data from two different tables, you're going to need to be able to join tables somehow. And so just to give you a quick conceptual teaser here, join is the operation you use in SQL to sort of merge two tables together. So by way of quick example, this top table here is taken from someone's database, and it's an employee database that has employee IDs and names. But in the orders table is where we actually keep track of who ordered what for their office supplies. Now you wouldn't the reason that we have two tables is for efficiency reasons. We don't need to, for instance, in our orders table, remember an employee's ID and their name again and again and again and again, right? We can factor that out and just put it in one place, the employees table. But if I now want to ask a question like, what is the name of the person that ordered a chair? I have to sort of conceptually somehow merge these two tables. I want to do something like combine this table with this one by kind of overlaying them in such a way that these fields here line up with these fields here. So what you get is one table that, and this is really a mess, looks like that. Right? There's a key in both. There's one in the employees table and orders. So if somehow you could take these two tables, sort of overlay them on top of each other, join them based on that unique identifier, then you can recover all of the information like who bought what. And so you'll see in problem set 7 that will give you syntax that uses something like this, joining something implicitly by mentioning two tables' names in a query. You'll see that you can explicitly say join. You'll see too that you're going to run into problems. And I'll tease you with just a dorm fridge example that we'll be having on Monday. But let me skip ahead to just this exciting slide that I put the most time into. So this is going to be the goal for problem set 7. The spec itself will walk you through anything and everything you need to know. So the fact that we didn't quite cover all the conceptual stuff is quite fine. What you will see then in this problem set that you'll be tasked with creating your own MySQL database with the help of the spec. You'll be creating your own PHP files, and so that at the end you have your own stock portfolio tool that actually pulls in real data from the stock market, which if nothing else is perhaps, at least on many people's minds these days, so now will perhaps be the time to buy with this. So see you on Monday.